Bom dia, bem-vindos à sessão plenária Solos, Restaurar e Recuperar Serviços de Ecossistemas. Iniciamos
Session. We will initiate our debate between the president of an organization in Egypt. He's going to join us via video conference, the coordinator for soils and hydrology from the United Kingdom, and Dulce Pereira, who is a professor at the Faculty of Economy and a researcher of a European project. Teresa Pinto Correia will be the moderator, the commissioner of the Science Meeting 2022. Good morning, everybody. This is the second day.
All of our Egyptian colleagues here. We also have Bridget and probably some others who do not speak Portuguese in the room. I'm very happy that we have this session on the soil, on the questions which have to do with restoring soils, providing ecosystem services, and how we can manage these and how we can relate to the different knowledge groups that are needed in order to solve soil questions. So we have both natural sciences, politicians, and social sciences. So I think it's a very good combination. I will give the floor first to our first speaker from Egypt. Thank you very much for accepting this invitation. I will ask you, please, not to take more than 15 minutes because we would like also to have a debate. Please, Professor Adel, the floor is yours. Thank you. There's no sound.
Participant, today I'm going to navigate from global to regional to national and then local and then back to international. We are facing great challenges which is impacting the environment and rupturing our planet Earth. I would focus on the issue of increasing temperature with climate change, and this publication is by the World Bank and it's warning the world from the increase to 4 centigrade in the future. Of course, this will result in affecting all the deltas in the world. They studied about 80 deltas, and the Mekong River and the River Nile, especially the delta in Egypt, is going to be affected. And therefore, this will affect sea level rise, which will be, I cannot understand your message in Portuguese, please. Can you say it in English? Huh? Okay, I will go slowly. And therefore, the issue of all the environment is going to be affected. Food production is going to be tremendously affected, as well as water, ecosystem, extreme weather conditions, and we all notice this everywhere in the world. And this, as well, there is a threat of irreversible change. This will affect only the land and soil, but affect aquaculture, and it affect the oceans and the feed for the fish, as well as fish production from the sea, and as well as animal zoonotic disease could really easily pass through borders. All this impact will affect agriculture in general. The world population now is 7.7 billion. We are heading to 11 to 12 billion by year 2100. More than 70% of the world population growth between 2010 and 2050 will happen from 24 countries of the world's poorest countries. And therefore, we need, as human inhabitants to this planet, we need to increase our food production by 70%. And this is in a time where there is expected reduction by the increased temperature more than the Paris Agreement, more than the 1.5 to 2 or 3 centigrade beyond year 2050. It means that we need to increase the food production by 70%, and we have reduction which is between 30 to 50%. And meanwhile, there is misuse of agricultural products by post-harvest losses in all commodities, which really range between 30 to 40%, which has to be taken care of. This is a part of the Global Development Goal, which was developed at the same year with the Paris Agreement in 2015, and the Sendai Protocol, which was signed in Japan by world leader in 2015 as well. And the 17 global goal, one of them is zero hunger, and this is a challenge for all of us. The climate change will impact biodiversity, which is the building block of the breeding program in producing a superior genetical makeup, and therefore we need to give attention to this genetical makeup in the future, as well as it will affect the quality of the production, it will affect the pathogen, the rust, as well as insects, and as well the underground bacteria, which is beneficial for the plant. We need to go to adaptation, which really matter for agriculture a lot, by two means. One is new genetical makeup, which is the variety which has heat tolerance to biotic and abiotic stresses, as well as new agro-management techniques and improve irrigation and nutrition, etc. This will require a massive program of human resource development and capacity building based knowledge. And for the new genetical makeup, there is avenues like using not only genetic engineering, but genome editing and development of C4 rice, nitrogen-fixing wheat, enhancing photosynthetic pathways, functional breeding, as well as develop biotic and abiotic varieties. For the new agro-management techniques, we need to go for precision agriculture, and we'll talk about it briefly. Therefore, we need to optimize the use of water, nutrients, and we use tools like remote sensing, simulation model, AI, artificial intelligence, and cloud computing. For instance, we need to have wheat production, which will tolerate drought. And in Egypt, there is a genetic engineering institute, which has produced one of the lines which has wheat-tolerant genes, and this was published in Physiol Plantarum. Other companies has produced maize, which is drought-tolerant. Gene editing will open a new venue in science toward the engineering of the new genetical makeup. For instance, this is an international wheat genome sequencing consortium, which produced these results, which will be essential for breeders to build on in improving wheat crop genetical makeup. The topics in agriculture, as well as there is tool of nanotechnology, which we can use it in food security and food quality, smart delivery system, biological labs and imaging, new tools for molecular and new cellular biology, new material for pathogen detection, environment protection, microarrays, genes and proteins, and nanoparticle complexes of DNA and peptides and ATP, etc. molecular machines and devices. Well, nanotechnology is here to stay. I mean, we can use nanosensors for grain storage, which will sense the moisture and the situation in the. In conclusion, nanotechnology in agriculture has begun and will continue new revolution, especially, but we need to take care of the nano biosafety. Climate change is affecting biodiversity. This is a gene bank in one of the international centers, which is ICARDA for the dry areas. It has about 250,000 accession, but war, as well as disrupted gene banks. For instance, in Iraq, it's been blown up totally. The gene bank, the collection for 30 years is gone. But we had a copy in the International Center of ICARDA, which we returned it back. There was a program to build up a huge gene bank in Svalbard. I was member of the board of this. It's called the Global Diversity Fund. And this is already built in to keep about 6 million accession in the glacial ice mountain in Svalbard. And this will be used for the whole world as safeguard for the future. Therefore, we need to focus on issues which relate to the climate change adaptation. And we have to look at technologies and institutions and policies which will cater for that. We need to use agriculture 4.0 with all the revolution on smart agriculture, which need to be embedded in, using AI in agriculture, drones, and as well as modern farming systems for water management, as well as for machine in the field and soil monitoring sensors, which is very important for the irrigation regime and to optimize water use efficiency. This is just an example on the regional level in Central West Asia and North Africa. ICARDA, as an international center for agricultural research in dry areas, has built up a benchmark network to monitor what's happening in the issue of increasing water use efficiency. Of course, farmers are going to be affected. This varies from Africa, as you can see, a severe impact on the African farmer, then Latin America, Middle East, and North Africa. Industrial countries will escape this, and as well as you can see here, different parts of the world is going to be impacted differently. I'm going to take you now directly through that the IPCC, we are in the 6th IPCC report now, and the IPCC in its report, it focused on issues which really relate to the global. We need to come from global to continental to regional, and we need to navigate through this in order to give information to the farmers in a local area of what will happen to them if the temperature increased to 3 centigrade. Therefore, we need to upscale and extrapolate, and then after that, looking at the similar ecosystem, agro-ecosystem, and then try to implement this there. What really important for the local people is what happened in his valley or in his particular valley, which has a particular environment, and it will have a particular change with the change of the temperature. We'll use all the modeling system to do this, and it will be adjusted. Therefore, we need to use advanced GIS as well as with modeling system in order to bring a spatial grid based on layer of information. Linking global to regional climate change is very important, and it is a must before we go forward, because what really matters is the hard-hit people who will need how they are going to keep with the impact of climate change. Science provides a lot of tools for us. We are talking about remote sensing, biotechnology, genomics and proteomics, simulation modeling, expert system, information technology, AI, renewable energy, new energy saving technique for desalination and water transportation and nanotechnology, etc. As for Egypt, as you can see, we are a green ribbon in the desert, and therefore we need to take care of a lot of issues. We need to take care of people and natural resources as well as the food production. The agricultural strategy in Egypt for 2050 the vision of it is to achieve comprehensive economical and social development based on dynamic agricultural sector, capable of sustained and rapid growth while paying special attention, helping the underprivileged social group and reducing rural poverty. Therefore, it's a science-based strategy, and we divided Egypt to 4 agroecological zones. Of course, we are facing the challenge here that without improving agriculture output, there is about 55% of Egypt population depend on agriculture and agriculture-related activity in agro-industry for their living. We need to go through a lot of aspects, legislation, rebuilding institutions. I will focus here on example, this sector produces about $42 billion income for Egypt and can bring more. I will just go through because I designed this presentation to be 20 minutes as I was told. I'm trying to go quicker now. The planned goal is to rationalize water and land use, human resource development, increase production and ensuring food security, promoting competitiveness, a livelihood improvement, and decreasing rural poverty. You can see this in the map. There is a red part, and the red part here is countries going to acute water poverty. Egypt is one of them. We are moving now toward 500 cubic meter of water. Beyond this, it will be acute water poverty. Therefore, we need to focus on maximizing water use in Egypt, and by doing this, we look at where and how in the different agro ecosystem in Egypt we can have a win story. We designed national program to improve irrigation system in different soils, and this will cover about 5 million acres. And therefore, we are hoping that with the implementation of this program, we will increase the irrigation efficiency from 50% to 75%. And this will save about 2 billion cubic meter of water, which can be used in the newly reclaimed areas. We are using all the new irrigation system. We introduced the nutrient film technique for soilless agriculture in early 80s. And we are moving on this, of course, using greenhouses in different shapes, using different agro-management techniques. The one thing which I would like to stress here, the human resources development, we need to focus on human resources development and provide them with the technology which will enable them to act accordingly. We need to as well look at the water resources and the land resources. Meanwhile, you need proper legislation, enabling legislation and policies to move forward. I'm not going to go into this as time is running. Then we need to look at the implementation of this plan. We are threatened, Egypt, because it has limited land base. In agriculture, we plant only about 8.5 million acres. By intensification, 180% intensification, we are moving to 200, but we need really to work hard with knowledge to see a difference. Otherwise, if we don't do this, we will face disruptions, and this is not going to be suitable. Therefore, the human resources and agricultural research, as you can see, Egypt is the Nile Valley and the Red Sea. Egypt is among the highest countries with scientific, with researchers working on the field of agriculture. But we need to pull all these forces, the universities, Agricultural Research Center, with the Ministry of Agriculture and other research activity under the same umbrella. Therefore, we can optimize the return. We need to rationalize the water use. We need, as I said, we need to focus on human resources. We need to increase annual agricultural growth rate, export growth rate, as well as the return per cubic meter of water and land and faddan, which is the unit of the land, as well as the rate of crop job generation. Rates of production, rates of creating jobs are really very important in judging if we are going in the right direction in farmer return. I will move here quicker, and this is just sum up the business plan whereby there will be a reclamation of another million faddan near the delta. They will increase the annual agricultural growth to 4.5%, create about nearly 1.6 million jobs, as well as increase irrigation efficiency by 75%, etc. This is, as I mentioned before, this is a repeated slide just to emphasize what we are heading for. Therefore, the goal here is to increase real sector contribution to the economy, raise the average profitability for small farmers, increase investment in agriculture, enhance agricultural labor productivity, reduce agricultural trade deficit, as well as employment. Therefore, this is what we hope to have at the end, which is a knowledge-intensive program for agriculture aiming at high level of bioeconomy. Therefore, the return from the bioeconomy in production of all agricultural commodity, including aquaculture, will be enough to really sustain, to have a major contribution to the economy in Egypt. Therefore, to do this, we need to have need-driven, knowledge-based economy, enabling environment, changing culture, drastic change in education, and this is what started, and most probably His Excellency Abdul Ghaffar, the Minister of Education in Egypt, has informed you about this. Therefore, we need to really focus on vision, imagination, creativity, and innovation. We need to go to smart agriculture. The issue of going upward is always difficult. You could stumble and come back if you don't really look very hard. The equation of the food crisis could affect political security, financial, economical stability, as well as food security. Therefore, if you don't take care of the issue of food security, this is what we will have. We will have a tsunami of misery. The issue for Europe is out-migration, which is really created out of the climate change, it will be between 200 million people up to 1 billion by year 2050. And this is a tremendous amount of environmental refugees everywhere in the world, as well as we have the young in the world are increasing in number. These people are either an asset for their nations or liability, because they are the first to revolt, they are the first to immigrate, and they cause socio-political upheaval in their countries as well as in the neighboring countries. This issue we need to avoid. The issue of conflict in water, we need to avoid it, and avoid it through rationale and wisdom and dialogues, and give the rights for the upper riparian and give prosperity for everybody in the river basin. Then adapting an institution to climate change is like snakes and ladder, which we played when we were young but still around, and we have to be very careful. We need to enhance the coping and the adapt capacity in all countries. We need to put our hand together, the international regional research system as well as with the national system. In Copenhagen, we said Copenhagen is Copenhagen. In Cancun, we said, yes, we can. We created the Green Climate Fund and the technology mechanism. Up till now, the fund is moving, but not as we expected. This is President Obama was regretting that we didn't act, but in Paris in 2015, they approved this. There is people who are supporting this, and political will of people like Abdul Kalam in India was very clear, supporting the plans to do something about climate change. This is Norman Borlaug, the Nobel Prize winner from agriculture, and he is a man who led work in Africa to overcome this. People like Mandela as well. Therefore, there is, the political will is very important in this. Our aim is to minimize the lack of coping capacity and the lack of adaptive capacity. Our aim is not with OECD countries and developing countries. We are hoping to move to peace and stability and prosperity based on exchange of knowledge and information coming out of science, regardless race, class, gender, age, ethnicity, or disability. We are hoping to shift. We are hoping for a shift of consciousness on the part of the have and the have-not, and the new understanding of wellness of humanity. I do thank you. Thank you.
Thank you very much, Professor Adel.
Hello?
Yes, yes. Thank you very much for
Do
your...
you hear me?
Yes. Yes, are you hearing us? Yeah, I would like to thank you very much for your contribution and for raising the awareness about all these problems we are facing. And we just go on to the next speaker with Bridget. Bridget was with me in the soil mission of the Horizon Europe, so we met there. There were a lot of disciplines gathering together, but Bridget, she's the real soil scientist, so she will talk to us about soil and what is needed to improve soil conditions. Thank you, Bridget.
Thank you, Teresa, and it's a pleasure to be here today with you this morning, and thank you for the invitation to talk about one of my favorite topics. And it's a very simple message compared to that amazing overview that we have just had from the previous speaker. And this is about soil. And I want to convince you all to love soil, protect it, and critically to restore it going forward. And it isn't just me who says this. Of a very long list of topics submitted to the EU about issues that need to be taken on as a mission, soil was only one of 5 selected. And those 5 topics, hopefully you're all aware, cover a very wide range of issues: cancer, climate change, sustainable cities, our oceans. And for us who've been working in soil for so long, it was just such a thrilling moment to have soil selected as one of the areas which needed transformative change, because we're in such trouble with it. It has been forgotten about, and now no more. We have an EU mission on it, which, as Teresa said, she and I both worked for 2 years on the mission board. There were 15 of us in total, and it was a very interesting experience. So next slide, please. Oh, it's me. I'm sorry. That's right. So first of all, why should we care about soil? What even is a healthy soil? What do we mean about it? Well, the mission created this definition, the continued capacity of soils to support ecosystem services. Ecosystem services isn't that great a phrase to communicate to general society, so we might perhaps more generally can say soil is critical to help control the flow of water and the quality of water. It is home to, it is estimated, nearly 25% of global biodiversity. And we don't even know what all that biodiversity is. That's how badly we know all the biodiversity, the microbes, the animals that live in the soil. It is really important for converting dead plant biomass into the constituent nutrients that plants then can reuse to grow again, nutrient cycling. It is really important to store carbon and therefore mitigate fossil fuel emissions. Soil is the biggest terrestrial store of carbon, far above that exists in all the vegetation, including the Amazon rainforests. It's also critical to support many landscape features and cultural services that give us our sense of identity, whether you are in Egypt or Portugal or where I am from in the UK. So soil, that's what soil should be doing for us. It is a huge array of benefits. So how are we doing looking after this precious resource? So if you think of our planet as a whole, only 29% is land. And of that 29% of that is land, i.e. that isn't ocean or ice, only about 70% of it is habitable, that we can actually work. And that means soil. So we are actually only 20% of the planet. We have to do all, that is our soil, that's all we've got to work with. And that soil has to produce all our food and our biomass. It has to support our cities and our towns and all those services that we need. So in the mission, we had a look at how we're doing. So we want healthy people, but it is estimated we have over 2.8 million contaminated sites in Europe. We don't even know what most of them are. 24% are inventoried, and very few are remediated. We need safe food. But 83% of EU soils have measurable amounts of pesticides in them. And very often, that is a complex mix of pesticides. And yet our regulatory system regulates pesticide by pesticide, control chemical by control chemical. We have very little understanding what that cocktail of contaminants has on us and on wildlife and nature. 21% of agricultural soils have cadmium levels above what is considered safe for drinking water. And we have heavy metal content that is considered unsafe for food production. And as I mentioned, our soils are absolutely critical as a store of carbon. So they can help us offset fossil fuels, and yet what are we doing? In our cropland soils where we till, over-fertilize very often, year on year we are releasing carbon into the atmosphere, when we should be capturing carbon into the soil. And in addition, it's estimated 50% of our peatlands, which are an extraordinary resource on store of carbon, we drain them to grow food and trees on them. And what happens then is, by definition, peats store carbon because they're anaerobic. If you drain them, they get full of oxygen, the microbes get to work, and they decompose all that peat, and they release CO2 into the atmosphere. So suddenly peatlands have gone from being one of our saviors to being a source of carbon, contributing to the climate change story. So we need our soils for continued biological production. They cannot do that if they are eroding into our rivers or through wind. 24% of our land has unsustainable water erosion rates. So that's these big storms. It should break your heart when you see those muddy rivers or roads which are full of mud. It takes about 100 years to build just a centimetre of soil. So when you have an erosion event where centimetres, if not more, is eroding off the land, that is hundreds of years of nature's work just being thrown away. It's a disaster. 25% of land is at high risk or risk of desertification. in southern, central, and eastern Europe. As I've mentioned, biodiversity. We don't even know what's in the soil. We haven't measured it all. And one element of the biodiversity that often surprises people is that most commonly used antibiotics that has probably saved quite a few of your lives or your family lives in this room, they originate from soil microorganisms. We don't even know which ones are destroying, which might be the next generation of antibiotics. The most recent antibiotic that was discovered was from a Maine grassland soil. Okay, something as boring as that, that's where a next generation of antibiotic came from, that as we have antimicrobial resistance is going to help transform and hopefully save many of our lives. And sustainable living. This statistic is one that I had absolutely no idea of, and I find it horrifying. Soil is the largest source of waste in the EU going to landfill. And this is just a complete silo thinking. Construction sites dig soil up for our motorways and our towns and our housing developments. And because we do not insist that that soil is reused and recycled, it is easier and cheaper to take it to landfill, rather than connecting and creating a circular economy. And most of that soil is not contaminated. There's nothing wrong with that soil, and yet we just send it to landfill. That should not be allowed. It should be regulated against. Because again, all that soil, it's hundreds, thousands of years of nature's work in creating that precious and relatively unrenewable resource. So we put all this evidence together. I have to say it was very hard work because there's very little evidence on soil health compared to all the information we have on water and air and biodiversity. Because there's no policy pool, there's no soil directive, very few countries actually have a national soil monitoring program. So we put it all together and we came up with the very sad conclusion that 60 to 70% of EU soil has some aspect of it that is going wrong, i.e. it's unhealthy. And that isn't just a problem for the farmers. It exists in our forestry land, they have erosion, in our urban systems they have contamination, and even on our nature land where our peatlands are drying out due to climate change. So what do we need to do differently? It is not going right now. We absolutely need to do something differently. So the mission identified 4 things we have to do for going forward. So the first is, we as soil scientists, and I totally include myself in this, need to come out of our bunker, come out of our lab, come out of our experimental farms, go and talk to the people who are trying to work with soil and say, what are your problems? Can we work together on this? Include the business, the whole market chain. Include our politicians, include our educators, include our advisors, include the social scientists. What is it that's limiting people doing things differently? We already know an awful lot about how to manage soils better. It is just not being done. Why is that? Is it lack of skills, education? Do the economics not add up? We need to identify this and create solutions together. So the mission is going to create 100 living labs and lighthouses. What is a living lab? It's getting out into the real world in real places to innovate and do experimental work. Critically, that work is to be transdisciplinary, working with a whole group of people across sectors, not a bunch of soil scientists thinking, we know what the problems are, we'll find the solution, we'll publish our nature paper, job done, next problem. It of course is a critical part of the scientific process, but if we want change, we have to then get out there and actually do this kind of transdisciplinary work. The idea is that these sites will be clusters of sites working at a regional or sub-regional level, so I would hope Portugal would be a country that would bid to be one of these 100 living labs. And then where something is shown to be working, so we have to be aware that we might fail. We might test a new technology, it fails, that's fine, move on. But where we do find things that work, we showcase that in what's called lighthouses, where people can come, talk to the manager, talk to the scientist, going, I'm interested in this technology, show me how it works, show me what your economics are like, show me what the risks are of doing it well. And that would be a lighthouse. The next thing, which is absolutely critical for every mission, and this was beaten into us so many times, a mission has to be specific, it has to have targets, you have to monitor it, and critically, it has to be understandable to the wider population. Otherwise, how do you know that you're getting where you want it to be? And that is what we really know now, that for policy to work, you have to have it very specific so you can track it going forward. So we set up 8 mission objectives. I won't go through them all, but there are 8 very clear things that we said we want to stop happening and change. So they're from desertification to reuse of soils. We don't just take a bit of soil, contaminate it, build in it. Oh dear, it's now easier, instead of remediating that soil, we'll go and get the next green field. We need to reuse our urban soils. We need to improve soil structure for biodiversity. But I'd like to draw your attention to the last 2, number 7 and number 8 there. One of the issues we have to have as a wealthy group of nations, apologies, the UK managed to burn our boats with that, is the global footprint. We must not enhance the environment of the European Union and just export the problems to Africa, to South America, to Asia. That is completely unethical. But how do we even know? There are footprinting approaches. None has been developed so far for soil, but we should develop that so that we know as we restore our own soils, we aren't just encouraging degradation somewhere else. And number 8 is improved soil literacy. How come no one was fighting for soils? Well, a few of us were. But compared to the biodiversity lobby or the clean air or a whole lot of other things, no one was out there fighting for soil. How did that happen? It's because we perhaps are very poor communicators. We haven't really gone out there and excited people about soil. That must never happen again, and we all need to take responsibility for including soil literacy, not just in the public, but also with our policymakers, with industry and everyone else. Specific targets. There's too much information on this slide. All I want you to look at is the green numbers. We have set very specific targets for each of the 8 objectives, okay, which we think are manageable, doable in the time frame that we've got by 2030 to do this. So we can actually say in 2030, did we succeed? Did we reduce soil sealing? Have we stopped 50% of pesticide use? Okay, so very specific numbers, with the exception, you can see, of number 7 and number 8, because we are only starting. We don't have good benchmarks for those, so we need to start from scratch there, and there is work to start that. And so we need indicators. What do we actually physically measure? And so some of these are very typical to us soil scientists. We need to know something about soil structure, so we need to know compaction. We need to measure the carbon. We need to measure nutrients and salt. We need to measure biodiversity and contaminants. But then we also need to measure the vegetation. If soil is bare and we are leaving it to just erode away, that is not great. And we need to get indicators, as I say, for soil literacy and the global footprint. So one of the things, even on the mission, I struggled with is many people have managed to convince themselves that soil monitoring is hard, expensive, it's too variable, and it's too slow to change. This is just not true. And I want to just try and convince you of this using an example. So the farmland bird indicator is one of the indicators that we use in the EU to assess the outcome of agri-environment schemes. It's totally accepted, everyone has to report it, we all do it. Now just think, birds migrate, they use multiple habitats, they go from farm to farm, and it's really hard to get a good number for birds, but we totally accept it. Soil, in comparison, stays where it is, unless it's being eroded. You can go back to the same place and measure it, and it's there, it's very well behaved. It doesn't have floods or droughts like water, it doesn't have transboundary flows like air, and yet we as soil scientists say it's too hard. What I'd suggest is we need to get out more. If you've worked with air, water, and biodiversity people, they have many more problems than we have. We just haven't funded it because there was no policy regulatory tool to do it. So here's the data just to persuade you of that. On the left-hand side, for the UK, apologies for that, is our farmland bird indicator. And you can see the index crashed in the 70s and 80s because our farming was just too intensive. We've managed to stabilize it, but we're struggling to get it back up. On the right-hand side, this is again from the 1970s to the present day, and this is soil carbon. We've been lucky enough in the UK, I've been part of the team that's been monitoring soil for 40 years. Tell me why that graph on the right is worse than the graph on the left. Tell me why the one on the right is any more less understandable to the population. The blue line is showing that year-on-year loss of carbon in our cropland soils. That is a tragedy, and we need to reverse it. So my answer is no. It really isn't. And furthermore, what we do is recognize that soil is part of a whole ecosystem. Soil doesn't act in isolation. Neither do plants, water, greenhouse gas emissions. So we run monitoring programs. We've got 2 of them, one at Great Britain level, one in Wales, where I live, where we actually monitor whole systems at the same time in the same place. So we can see if soil is changing, that is because the vegetation's changing, which is because the management's changing. And that is impacting on the water and the greenhouse gases and the pollinators and the birds. And you can start to see that whole connection between all these different components. It is incredibly efficient and economic to do compared to having multiple monitoring programs, which are all in different places, that you then need really complex data science to link up. If you measure them all in the same time, in the same place, you can connect them automatically in an integrated way. The third building block is to encourage everyone to learn more about soil. We must not ever have soil falling off the radar again. Let's excite the young people. Let's teach it in schools. Let's take it out into our parliaments. And so during COVID, we all had to go online, and I had a fantastic experience working with the BBC and the Royal Society to create an animation film. It's a very short animation film. It's only 4 minutes long. And it's basically a way of trying to communicate some of the fascinating facts about soil and why everyone should care about it. If you can see there on the right-hand side, 150,000 views of this film. None of my research papers have had that level of interest. And so, you know, I'm really excited about this. They're award-winning animation films. It's a lovely film. I encourage you to go and look at it, and encourage all of you to connect up to some individuals like this to try and excite people more. The other thing we did during COVID was we created an online community hub where we screened a whole lot of information on the web, which is all over the place. Some of it's completely mad and frankly wrong. So we didn't allow that to go in our hub, and instead we put together information that we thought was robust and fair for things like films and blogs and books, training courses. So there's one-stop shop. We don't create this content, we just link to it. So there's one place you can go to, and you can access the best of. So if you need a teaching course, or you've got some kids you want to know, I want an activity for family, you can go here, and there's examples of what you can do. So the final thing is research and innovation. And we heard of some fantastic examples of high technology solutions from our previous speaker. So gene editing, artificial intelligence, Earth observation, sensors. I just want to give a different angle on that. And they're not mutually exclusive, is we need to work with nature as well. Nature can help us here. Let's not fight against it. Let's work with it. So we need to have increased use and reuse of organic matter, nutrients, and water, create that circular economy. We've got to get away from, we use it once, we throw it away, we go and get the next resource. So we were hearing from the previous speaker, sensors for water use, sensors for nutrients. Don't just put it on because you've always put the fertilizer on. Is there actually evidence that there's a shortage of fertilizer in your soil? Do you need to apply it again? Reduce use of control chemicals and develop integrated pest management, which means rotations, diversity. Don't just automatically put on chemicals. It does take education, it takes faith. It's risky, but we need to do it if we're going to stop building up this cocktail of chemicals in the soil, which perhaps are okay, perhaps isn't. As we don't regulate for the cocktail, but individual, we don't even know. We heard about tillage and traffic and animal management. There is some truly shocking, probably when you just wander around and you see the compaction, the erosion, and there are approaches to this. Robotics might be one. There's just simple things like broader-based tires that we can look at. And also soil cover, just trying to get more vegetation to cover up this precious resource more frequently for more of the year in more diverse systems. So just to iterate, these are the 4 building blocks. Starting in the bottom right, we need living labs and lighthouses where we co-create. What are the actual problems? What would be realistic solutions? Who wants to work with us? Do we have a market chain that can build it into the circular economy? can we make sure when we develop those systems that we're monitoring what the outcomes are? We don't just say, oh, it works. Well, how do you know it works? Let's try and use the same indicators and build that into the new set of national monitoring programs and the EU monitoring program, which is called LUCAS. Then let's communicate it. Let's encourage people to come into these living labs and lighthouses and understand how things can be improved. We don't just have to give up. You know, soil can be exciting. We didn't used to think plastics were exciting, and yet there's now a global phenomenon on plastic waste in the oceans. And finally, we do need new innovation, new ideas, take risks, try and deploy new technology, but also working with nature. Joined up framework, so now at the bottom we've got a mission which is getting funding mechanisms to actually develop those living labs, those indicators for monitoring, roadmaps. We have a policy framework, we've got a new soil strategy, and we've got the new EU Soil Observatory, which is going to collate all the data from Earth observation, from the National Soil Monitoring Programme, from LUCAS, from citizen science, put it all together so that we have robust data, evidence going forward as to whether the mission is actually succeeding, so we can adapt as we go forward. And also, hopefully you all know, rather to all of our surprise, there's a consultation now on a new soil health law, because perhaps regulation, perhaps we do need a stick, as well as encouraging everyone, perhaps just as we have for water, air, and biodiversity, we do actually need to have regulations and rules to stop people abusing the soil, contaminating our rivers, enhancing climate change. We really probably should stop those bad behaviors, just as we do for all the other natural assets we have. So I've given you a lot of information, but looking forward, the message to you all is it involves all of you, not just as soil scientists. All of us have things to do with our children, with our policymakers, with our farms, with our gardens. There's things to do. Here's a whole lot of useful links. I don't expect you to copy them down, but they are going to be in my talk, which, as I understand it, is going to be made available. And with that, I'll thank you and offer any questions. Thanks, Teresa.
Thank you very much, Bridget. We will have a small time for questions later on. Thank you very much for bringing the soil really into the floor and what we need to do about soils. Now we'll move to another sphere of science contribution, which is from social sciences, from history. And I think Dulce is going to tell us about traditional seeds and the relation, what they do for teaching us about the relation between environment and human activities. Thank you.
Muito bom dia, muito obrigada pelo...
Good morning. Thank you very much for the invitation to be here to speak about the research we have been doing. I titled my presentation Invisible Soils because in truth it seems that soils, the earth, are still invisible because they are under our feet, our cities, our rivers, food products that grow, but also invisible from the historic point of view. We are still using indicators built on data from 20, 30 years. We may have these indicators built with more sound data with 400, 500 hours, and I will try to convince you of this over the next minutes. The ReSeed project is funded by the European Research Council, is being dealt with in Coimbra University. Focus are food issues to try to understand what was the impact of the products that from the 15th, 16th century started to arrive to Europe from other areas in the world, transforming our agriculture, our food, our diets. What we consider our local products, our traditional products, our kitchen or farm tradition was built with these products. But in truth, we know very little about how they entered our different farming systems, what changes did they provoke, what varieties were cultivated, how maize and potato became a local diet in Europe, and we don't know how we were connected those varieties or those species when they came to Europe. And also, we don't know what happened, either what was being cultivated here. For many, many years, the Iberian Peninsula had a variety of species and foods, or many grains and vegetables that today are unknown. That meanwhile changed in the farming system. So we want to understand these changes. As you say in the title, we say that we are studying since the 18th century, but it was necessary to go back. We have a multidisciplinary team with biologists and historians who know different history periods, geographers, and other social scientists. So they are studying the 15th and 16th centuries, because without knowing what happened at that time, we are unable to understand what happened during the latest 200 and 300 years. The Iberian Peninsula has been, over the last centuries, a peripheral area, or ultra-peripheral areas in Europe. But we forget that in the past, it was the center. The Iberian Peninsula was the center of the world, and it was an entry gate to all the products that change our lives and the previous generations' lives, and the agriculture as it is today. So it's important to understand that soil sciences started to be developed from the end of 19th and 20th centuries. Knowledge produced from and the end of 19th century. It's the knowledge available in the mainstream areas at that time, in the 18th, 19th, and 20th centuries. The Anglo-Saxon, French, and German cultures. It was difficult. It has been difficult to integrate in scientific explanations and scientific knowledge that today we have available regarding the sciences of soil. Another important matter, we understand that, and our research has shown that in order to understand changes in the use and operation and conservation and restoration of the production conditions, food production conditions, and not only, it is important to have a long-term perspective. And it is important to include the knowledge from the past. And when we speak about the knowledge of the past, we don't speak about the knowledge produced over the last 100, 200 years. It's important, but it's not enough to understand and to create credible models with reliable and robust indicators about the dynamics of transformation and use of soil. Also, it is important to understand local knowledge. Local knowledge, as we know, is fundamental for us to understand changes in agriculture, to understand what has been done and what will be done, to build solutions, farming solutions adapted to each location. And this knowledge, local knowledge, can be improved having a good historic data knowledge on how and what was cultivated and the conditions of the farming systems from the past. And for that, we built a methodology based on words. We want to capture information that are written. Most documents and most things we have until the computer era, and joining this with what is published. What we have published is different from what is written documents. It has benefit from the disclosure of the printing methods. We know that from the 16th century this happened. So the amount of books increased from that time. We want to also compare this with the current practices together with the station of Elvas in Alentejo. and also with the farmers. I came from a storm over the last 3 months, so we want to connect this past information that we come across in historic documentation with what are the memories who have already practiced agriculture, or with the current practices of agriculture of farmers that tend to overcome industrial agricultural problems. I will not detail this, but the results or outcomes we come across are very important, difficult to obtain. It's something we have to do. I start by speaking about some authors, important people who were important in the building of scientific knowledge about the soil in the Iberian Peninsula. Authors, Herrera is a pioneering author, publishes an agricultural manual at the beginning of the 16th century, collecting a long heritage from the Roman and Greek classics and from Muslims classics who were very important, as you know, in the Iberian Peninsula. It's enough to remember that politicians in the Iberian Peninsula, Muslims, until 1492, Colombo was about to find America, and at the same time there were kingdoms, Muslims kingdoms in the Iberian Peninsula. They had a long stay in this area, and really it was not valued in the next centuries, but what they did was really very important, and some authors of this period integrated this knowledge. And there is a commitment also with the knowledge, Catholic knowledge. In this case, this conception that the earth is always fertile, never gets tired, so humans have to only be able to produce, the earth is a divine thing. It's the human art and handicraft that should be able to produce and to harvest the earth. So these authors start to give instructions in that direction, and then we start to see that from the 16th century, a growing incorporation of the local experience and local knowledge and social knowledge, the knowledge that is born from each community, from the different regions. I will not detail many authors, many references, but in truth, what we understand, and that's why these books are so important. After the 16th century, the individual experience starts to, and the observations start to be important, creating the conditions for what we will consider to be modern science. So there is a number of data. Quite often these authors were abandoned by several reasons. Two of them because they wrote in Portuguese, in Catalan or Spanish regional languages, when at that time the scientific language was Latin. So when they were not translated, Herrera had an English version only in the 21st century. So they were not understood. So this knowledge didn't go beyond the Iberian Peninsula. They say, well, the main concern is agriculture to produce food, but simultaneously they have a perspective of conservation for those conditions to produce food. All the options, farming options in these books, it doesn't mean that the practice would always be like that. They promote conservation of soils, a rational, a delicate use of water and available resources. So they give us a number of data for us to understand how the several factors are conjugated that promote the production of food without appreciating the conditions of soil and natural resources allowing for this production. They start to also give indications about the classification of soils, something that will be important from the development of the sciences of soil. Miguel Agustin is an author from the 17th century. They integrate more local knowledge, more knowledge about their own experience, the religious component, and superstition. There is a tension between natural and supernatural, which is present in these works, so that's why they have been abandoned. But this presence decreases as we progress over time. So they give us indications about important issues. What are the characteristics of the soil and how soil changes and how these conditions change over the centuries. I bring you also João António Garrido for interesting reasons. The first agricultural manual is from Herrera, and some years later the first Portuguese work is this. It's a Luso-Spanish author that gives you a very interesting knowledge because it summarizes the knowledge from previous authors and gives you a comparison between what was being done in Portugal and Spain and in the several regions of Spain he knows, and also in the several regions in Portugal. He speaks about the influence of temperatures, the influence of the geological characteristics in the food production, and also how the use of these factors, or how these factors can be used to the benefit of the economy and agriculture and common good. It is an author that makes the transition between science, between the previous knowledge from the period before 18th century and then the later years. Concluding, it's important to take into account that there is an important innovative knowledge that in the 15th, 16th, 17th, and 18th centuries is being produced in the Iberian Peninsula. These regions have a privileged knowledge and the privileged contact with the New World as we usually call it. He introduces important components that will be key for scientific development that takes place afterwards. These references are invisible. There is an important weight of the references of inheritances from the Catholic Church. All the books to be published had to be approved by religious authorities. They had to make a commitment, otherwise the works would not be published. So they give us an updated knowledge about soil and production conditions at local level. So these books were really circulated in the Iberian Peninsula, were translated, some of them translated into French and Italian. But if it had an impact it really had an impact in the different regions. It's important to develop this knowledge and to understand these contributions in light with the current demands to build sustainable knowledge
sobre a agricultura e sobre
about agriculture and about the use conditions of the natural resources, and we consider that this knowledge should be included, and there are conditions to include them in scientific debate nowadays. Thank you.
Muito obrigada, Dulce. É realmente muito interessante.
Thank you, Dulce. It's so interesting how this historical perspective brings a different dimension into the understanding soils and the relationship we have with soils. I think we don't have much time left, but we still have some. So maybe we could take a couple of questions from the audience. So while you're thinking about the questions you'd like to ask.
2 questions, we'll have the time for a small, very small debate. I have one question to you both, which is the this approach, which is the approach of the mission. It's to install, or the aim finally of the soil deal is to install these 100 living labs across Europe, and the living labs can be of different scales, but the idea is really to use contextualized knowledge and also local problems, and deal with these problems from different disciplinary fields and understand how can we best solve them, from soil sciences to behavioral science to economy to landscape approaches. So the question is whether you agree this will be the way forward, and if scientists are ready to do this, or what do we need in terms of, do we need other award mechanisms so that we are recognized by doing this work in the context? Do we need to mix more sciences? Is this the way? Or what will be the approach which can make these living labs successful? Because they are presented, we talk a lot about them, but how they really are going to work, if we want to engage scientists with local people, this is not easy. This is not something we are trained to do. And with policy making at a very local municipal level, maybe, how are we going to do this? What are the keys? But first, before you reply, I'll just look to see if there's anyone else who wants to make a question, then we will combine. Yes? Okay. You can make your question now. That will be okay. Then we'll have the two questions. Do you have a mic? No? Okay. Then you can take my mic. Please present yourself.
Thank you very much. My name is Mahmoud Sa'ri from the Academy of Scientific Research and Technology, Arab Republic of Egypt. It's not a question, just first of all, thank you message to the organizer for the very interesting, actually, speaker this morning. I enjoyed very much the speech from Professor Adel Beltagi, former Minister of Agriculture in Egypt and former CEO of ICARDA and many international positions, as well of our colleagues from EU Commission regarding the health of soil and the new, actually, prospect from historical point of view. So thank you very much. I enjoyed very much the speech. My first comment for Professor Beltagi is to highlight and to pay much attention to wild, saline, and dryland agriculture. Of course, deploying of technologies, genetic engineering, genome editing, and other, it's important actually to support country efforts to adapt to climate changes. But at the same level of importance is to pay too much attention to nature conservation, to saline agriculture, to wild relatives, and so on. Now is the time actually is to pay too much attention to nature conservation, to back to the nature. If you remember a long time ago in 1950 and 1960,
please, you have to be brief.
Yeah, sorry. The Green Revolution paid too much attention to increase food productivity. Based on what? Based on application of external fertilizers, chemical, pesticides, and so on. And after more than 50 years, we noticed that this was something not good, at least for the health of the soil. So now the time actually is to monitor in more details the health of the soil, not only in EU, but worldwide. We are in their need for something like soil health record to monitor. I believe, and I'm quite sure, that the nutritional requirements of plants now are quite different from 50 years ago. I'm quite sure that the accumulation of chemical fertilizers along 50 years makes some sort of disturbance in the nutrient in the soil. This is my comment. Thank you. I would like to save the time for others, but I like it very much. Thank you.
Thank you very much. Thank you. So, okay, I will give you the floor to both of you. I don't know who wants to start. Maybe Bridget, you talked first, and then we have the tools.
Okay, well, to come to Teresa's question about the living labs, they will be very difficult, and I don't think every soil scientist will want to or be able to engage. And I think that is fine. We just need to find that group who really want to spend and invest the time to find the common language, to really work with people in other disciplines, but also other sectors, and to take the time. But it's going to require funding to build the trust, the social capital, which actually, if you're on the fast track of science and how we judge people, that is quite a commitment. You're not going to be writing your papers in that time. So I think it's about long-term commitment here, finding the people, encouraging the next generation to want to do this, to ask them, do you want another paper, or do you want another paper and really help to change our world? I mean, and have real impact in a way. But it is going to take time. These aren't 3-year projects. Living Labs is not a 3-year project. It's 3 years probably to even get the debate going, and then we need to do things. So I believe it is the way to go, but it's a long-term commitment. Thank you.
Thank you.
Yes. I entirely agree with you. I think history can help to establish the link between the local problems, the nowadays local problems, and the historical identity, the past. So we are doing field work. The research team are doing field work now in different areas of Portugal and Spain. And when we go through the people, when we meet the agriculture, the farmers, or the technicians, and when we talk, and when we show that we know what was going on in their lands, then we can start to talk. Because local knowledge is very important for local people. So if you come from outside the local area, but if you know what was going on in this local. So I think historical research, and we have the tools, and we have the historical resources to do this kind of research. But it's not a project for 3 years or even for 5 years as an ERC project. In fact, it's something more. It requires more time and a lot of energy to work with farmers and to work with a lot of different local entities related to agriculture or related to conservation sciences.
But in your project, are you then monitoring practices also, and the actual practices, how they are built on this traditional knowledge, or
we are trying to connect the local the local practices, how they are farming today, or how they farming during the last 30 or 20 years, or what you can call traditional farming. With the historical documents. We are trying to establish links between the information that we catch in the documents from the 16th or 17th or 18th century, and we are going to these locals to see if there are some kind of memory or a kind of something survived of these old practices.
Yeah. Because in fact, I think one of the key issues is to mobilize them, to get them engaged in discussing with researchers, with scholars, and then to see where they find solutions. So these different approaches is requires from the soil scientists that they are a kind of soil scientists interested in that, but then also that we give the time for the locals or the farmers to engage in this discussion and continue with it. So there's a long way. I think this interaction between the soil scientists and then other types of scientists, and namely social science, is extremely important. I hope we have more time for discuss these interactions along the day. Today there's a lot of thematic sessions which are on this, how to build these bridges and to build the bridges to society and to policy. So for now, I would like to close. I would like to thank you very much. We have the closing session, and now we kept the time. Thank you very much. Thank you.
Agradeço aos participantes de...
Thank you. I would like to thank the speakers and to invite and to pass on the floor to Ms. Rui Martinho.
Muito bom dia a todos. Eu começo por referir que...
Good morning everybody. I would like to mention that I am on behalf of the Minister of Agriculture who's been unable to attend the session due to an unforeseen last-minute commitment. But I do have a very clear message to share regarding our governance policy on agriculture and the topic that the Science and Technology Foundation has chosen for today, and also the very relevant relationship that should exist amongst different governance area, namely our farming and also higher education and agriculture. Good morning, everybody. Good morning, everybody. I would like to greet everyone.
Mrs. Helena Pereira, Ciência Viva representative, Mr. Vargas, Professor Teresa Pinto Correia, Commissioner for the Science Meeting 2022. I would like to start by starting my speech with a word to pay homage to Professor Mariano Gago, the mentor of these meetings about science. His legacy will always be a reference and a source of inspiration for the new generations that search knowledge. It is good to come back to these fora, the good times when we had to find different ways to promote science. It's a source, a big source of ideas. Our society needs more science and innovation. Key pillars in the definition of new ways of valuing resources, optimization of the production methods, and more responsible consumption. Promotion of research, innovation, and empowerment is a strategic essential line in valuing the Portuguese agriculture. We would like to promote digitalization and application of information and communication technologies in order to improve productivity, and knowledge being a factor of competitiveness and equality. It is fundamental to aggregate scientific knowledge, artificial intelligence tools, advanced equipment, and big data in order for us to be able to develop solutions to apply to different farming systems. In short, there is a need to continue to bet on democratization, modernization of agriculture. About the subject of this plenary session, I would like to draw your attention to some data that were discussed during the panel of this morning session. 33% of the soils are degraded. Soil accommodates more than 25% of biodiversity in the planet. Healthy soils are the biggest Earth reservoir of carbon in the planet, fundamental in the accumulation of on climate change. 70% of the European Union soils are not in a healthy situation. Every year, approximately 1,000 million tons of soil are taken away by erosion. In Portugal, 64% of soils we have a high level of susceptibility to drought and desertification, regardless of the climate change conditions. Soils are a natural resource that produces indispensable goods and services to human life, mainly in the production of food and food security. Portugal and the Ministry of Agriculture are still committed to international initiatives, global partnership of soils in the United Nations and the European partnerships for soils. The aim is for the balance of the degradation of earth, of land is neutral, applying resilient methodologies, reducing contamination. It's important to underline the principles that are at the core of the strategy of biodiversity. I would like to underline, as example, some objectives to revert at least 10% or reconvert at least 10% of the agricultural surface in landscape of great diversity, to reduce losses of nutrients and the risks of chemical pesticides, to increase the percentage of land in the regime of biological farming, and increasing significantly the organic matter of our soils. The soil strategy of the European Union for 2020 establishes a clear objective. Until 2050, all ecosystems of soil of the European Union should be in healthy conditions. This is really a very important regulation for Portugal, so we need to do a comprehensive participative discussion for us to listen to the several stakeholders in this sector. It's important about this to say that we don't have a unique revenue applied to all soils or to all types of earth use. There is a growing volume of knowledge subject to be used in agriculture, demanding national effort in order to assess these practices and to increase dissemination in this matter. In addition to other support related to the improvement of the management of human resources, we include specific support and grants to protect soil, namely the measure conservation of soils. This is a program and a measure that exists since 2015 at least, in a sustainable, consistent way, and we have already included more than 2,000 farmers in each campaign. This number of farmers that adhere to this practice increased to more than 4,500, and the amount we normally give is really very significant. We are preparing and ending a strategic plan for a CAP program, including specific domains dedicated to soils and also specific objectives in order to promote efficient management of soil management. I underline the eco-regimes aiming to increase the capacity or to increase carbon in the soil and to protect the soil against erosion. It will be promoted an efficient use of resources. We transition to a low carbon content of carbon resistant to climate change in farming, namely through measures such as promotion of a sustainable way of permanent pastures, instead replacement of fertilization or mineral synthesis fertilization. I would like to also refer the plan, the Resilience and Recovery Plan. Within the component 5 capitalization innovation of PR, the Innovation Agency was included in Agriculture 2020, and we launched 11 notifications for invitation to tenders for recovery of ecosystems and the use of soil as absolute priorities in the use of specific measures. I would like to conclude underlying that agriculture does not quit following up technological innovations, and it is an engine for change. We have to ensure quality, safe food without compromising future generations. Science is important for us to be able to meet these objectives. I remember again Mariano Gago in one of his inspiring sentences: "No one knows enough to do everything alone." Thank you.
Damos por encerrada a sessão plenária do segundo dia do Encontro.
The plenary session is therefore closed. Later we will come back with green, sustainable, inclusive cities. Meanwhile, visit theme sessions. Thank you. See you soon.
esta sessão vai ser...
This session is going to be a little bit different because I don't have my partner, our Egyptian colleague, Mohammed, who is lost. I don't know, maybe he was called to do something else. So I'm here alone with you. It doesn't matter because this will give us more time to perhaps interact between ourselves about this subject. Well, the subject is a very interesting subject, very important, because it has to do with how a program, European program, the PRIMA, works. It's a program which is really quite different from the research programs we have in Europe. Includes countries from Europe and also countries from Africa and from the Middle East. About the Mediterranean basin, the subjects are really of interest for this region. They have to do with, we heard, by the way, during the plenary session, many of these subjects, it has to do with climate change. Climate change is really a concern to these regions in the Mediterranean area, fragile regions from this point of view, which will have to be adapted or to make some forecasts for the future. In addition to climate change, the PRIMA has the aim to develop work about agriculture, always according to the sustainability approach, valorization of endogenous natural resources in the region, knowing them, valuing them, applying them, and the food issue is also a key in the program, development of food security or safety, and also intelligent management of water, which is obviously a component that is of interest to these countries around the Mediterranean Sea. How PRIMA works? Let me ask you a question. Do you know PRIMA and how it works? Do you? Who knows the program? Could you please raise your hand? Well, 3 of you know it. 4? 1 more or less. But I see that some people don't know it. And this session aims to also disclose this program. You will ask maybe, why? Why do we need that? Because, well, it's very important for everyone to know the program, because one of the political and science purposes are to increase Portuguese participation in European funding and programs. All of us, both from the government and the institutions' point of view, who apply government guidelines such as FCD, and also the whole scientific community, they should work in order to increase, optimize, develop participation in European projects. So the more we know these European programs, the more we are capable to be adapted, to participate, and hopefully to win and to bring to Portugal more funding for science coming from European funds. So in this case, in the PRIMA case, and I will tell you how it works from the practical point of view. This is particularly interesting because it requires participation with the countries in the Mediterranean Sea. So science today is not made isolatedly. It's not a research center. Any research center is not the only hub. We have a global approach nowadays to be in contact with other realities, other countries, and that will allow us to take important steps forward and to have the knowledge and to be able to apply that knowledge. These interchange, which are not the classical countries of our European interchange, is very important. So the primer is really in the middle of its life. It was launched, open tenders during 4 years, and it's in the middle of its duration. We still have 4 or 5 more years of tenders, and tenders have always a page which I advise you to read, the primer page. So it's about the key issues I have mentioned, the obligation to have the collaboration of countries from the north of Europe and also from the south of Europe. FCT has really actively participated in the program since the beginning. We were working the concept, and it was not from the point of view of any European regulation. It was not easy because it's not easy to create out-of-the-box things. It was a process which was really took more time. But Portugal started from the beginning, and we have been following it up over the years during the opening of a public tender, being involved with the scientific part of the program, FCT. Maria Maia, are you there? Maria João Maia is there. She is our delegate to the program. Therefore, any questions, any practical support, any information you may need, any support to have some contacts, you have here Maria Maia as a connecting point with FCT, and obviously myself, but sometimes it will be quicker to contact Maria. So we have annual public tenders in 2 ways. One, named Section 1. It's not a sexy name, but it's what it is. Funding of those projects is given fully by the European Commission. And then we have Section 2. The themes are the same in both cases, and in Section 2, funding is given by the participating countries. Suppose it's a collaboration project between a Portuguese team, a Spanish team, an Egyptian team, and a Tunisian team. Funding is given by these 4 countries to their teams. So the tender takes place as any other tender. You are used to RCT public tenders, and this tender is quite similar. We have to submit a bid, what we will do, the goals of the project, the tasks we are going to be involved with, the outcomes we expect, the rationale that is behind this, and obviously the consortia, the partnerships. Evaluation is also done as usual. There is an international panel that evaluate the applications, the bids. There are two evaluation phases. This is the difference, two phases. One where those projects with less classification or scores are taken away, and a second phase with a smaller number of projects. And at the end, they select them by scoring order. The success rate, let me tell you, is not very big in all of them. This is a constant thing in science. Almost every application or bid, national or international, we always have a bigger number of projects than the allocation we have for funding. The success rate is not as high as we would like it to be. Portugal has participated actively. We have lost some bids, won some of the bids, but we have some projects going on. And we have with us today some people. Paulo is here. Let me see. I have to read my notes because COVID has given us many surprises. We have lost some people. Filomena Botelho is there. Yes, Filomena Botelho. And from IBET is there. Maybe I would like to ask you, the three of you, to join me at the stage. And as you see, we have an informal